So in this question, we're asked to find the total energy released from the beta decay of a neutron. And the units are specified to be mega electron volts. Well, what is the beta decay of a neutron? Well, what we have is first just a solitary neutron, and it's going to decay into a proton. Just to be clear, that's positively charged, and it's also going to have an electron and also a neutrino, technically an antineutrino. Okay, technically an anti-electron neutrino, but we're not doing too much particle physics here. Now, the idea here is that we want to look at the change in mass. And from that change in mass, we're going to see how much energy is released. It's worth noting that for all practical purposes, a neutrino is massless. It's not actually massless, but it's really small, and took decades and decades of work to figure out that it even had mass. Okay. So let's take a look at that change in mass. So our delta M, well, we're going to have the mass of the neutron minus the mass of the proton minus the mass of the electron. Now, because we were asked to do this problem with a final answer in mega electron volts, it is convenient for us to look at mass in terms of mega electron volts per c squared. And these values can be looked up usually in a table. So the mass of a neutron is 939.57 mega electron volts c squared. And similarly for the others. Okay, so if we do the subtraction here, we end up with a difference in mass of 0.78 mega electron volts per c squared. And so this type of question demonstrates the utility of using mega electron volts per c squared, which sounds a little awkward at first, but when you're doing this type of work and we want the energy released, well, that type of unit is very convenient. So we've got 0.78 mega electron volts divided by c squared, and our equation here is E is equal to our, really it's our change in mass c squared, and I think you probably see how easy this part becomes. So our energy is going to be 0.78 mega electron volts. And that's why that unit is very convenient under these types of problems. We're done.